Today's lecture is part 2 of our slope stability for chapter 7. In the previous lecture we discussed the modes of failure, shapes of failure, all the data concerning the stability of slopes. In today's lecture, we are going to study the first method for the analysis of the stability of slopes. I need to check, is this slope stable or not? I cannot just tell you that this slope is stable. How much is it stable? Is this stable more or another slope is stable more? To know this, I then have to use numbers. When you tell me that this slope is stable, then I will ask you what is the factor of safety of this slope. If you tell me that I have a factor of safety of 3 and somebody else tell me that he has a slope with a factor of safety of 4, then his slope with a factor of safety of 4 is more stable than a slope of factor of safety of 3, and so on. What are the forces causing the slope failure? To see this, we'll just go to any shape of failure, something like this. Imagine that we have this shape. This is a general shape for slope stability. So let's see what are the weight of the wedge. If I increase the weight of this wedge, the weight of this wedge will be something like a force here in the middle going down. If this force increases, then the force wants to push the slope down. So it is not increasing the stability, but it is decreasing the stability. So this is the first thing, which is weight of the slope. Second thing is the seepage forces. Suppose you have water here, and water is seeping here going down. So it is as if it is pushing the soil with it. So seeping water, because it goes from the higher to the lower. So seepage water in general decreases the stability of the slope. Earthquake destroys anything. If you have earthquake, forces are in all directions. You cannot judge from where the force is going to come. So earthquake forces will decrease the stability of the slope. Surcharge weight. If I have here a building on top of this area, so this building is as if it is an increase in the own weight of the slope, because it is a weight on top of the own weight of the slope itself. So it is increasing the weight of the slope, so it is decreasing the factor of safety. So surcharge also is the same. Then we said that factors leading to instability are classified as factors causing increased stress on slope or factor causing reduction of strength of soil. So for this slope to fail, I may do two things: increase the loads or the stresses on the slope, or reduce the strength of the soil. You are standing carrying a weight. I'm naughty boy and I want to let you fall down. So either I give you additional load to carry, so you will fall down, or I do anything that would reduce your strength. If I reduce your strength, then you will fall down even you are carrying the same amount of load. Like give you a kick in the leg, you are going to fall down. It's the same load, it has not changed, but your ability to carry decreased. So this is what it means. It's either I increase the stress or the load on the slope, or decrease the strength of the soil that is carrying the load. What are the factors causing increased stress on slope? This is a repetition of what we have said. If I increase the unit weight of the material, it will increase the load. The load will increase. If I add external load, then the load will increase. If I make the slope steeper, it means that instead of having a slope like this, I make it starting from here and going there, as if it is 90 degrees. 90 degree is a stable slope? No. If you think that there is soil and you can let it stand 90 degree, if you have sand, can you make sand and let it stand 90 degree? No, by any means no. Okay, let's try 80. Still no. 70. No. Till we go to say 45, you will tell me okay, it is okay. 30, very, very good. So a steeper slope means failure. A less steeper slope means that the factor of safety is good. So this is what we have said here. I should go to this one. Steeper slope. Factors causing reduction of soil strength, the opposite. But I want to reduce the strength of the soil. Cyclic loading, as we said, cyclic loading will induce in some cases a reduction in the soil strength due to the increased pore pressure in the soil and so on. So cyclic loading may reduce the strength of the soil. Adding water to the slope, maybe the slope was dry. If I add water, then in this case there will be a reduction in the strength of the soil. Increasing the pore pressure. In general, here cyclic loading affects it in this way, but in general, in anything that would cause an increase in the pore pressure will reduce the strength of the soil. So what is the factor of safety? Now, we said that this is our target. The target of this lecture is to reach the factor of safety of the slope. Is it stable or not stable? But I don't want description. I don't want to tell you that this is very stable or less stable. I don't want this. I want you to give me, this is stable, number 3. This is stable, number 2. So number 3 is better than number 2. But what is this number? Is the factor of safety. The factor of safety, from the name, a factor of safety means whatever that is carrying me divided by whatever what is causing me to fall down. The example I said last time, if I'm standing and one of my friends is pushing me to fall and another is pushing me to stay in place, then my factor of safety would be the strength of whoever is trying to keep me in place over the strength of the person who is pushing me. If the person who is keeping me in place is very strong, then I will be safe. But if he is very small and he cannot carry anything and very weak, then I will fall down. So this is the factor of safety. So what is carrying the slope? It's the shear strength of the soil. Is the soil capable of carrying shear strength or not? What is the shear strength of the soil? What you have done in your lab tests, in the lab tests you calculated C and phi. If these C and phi are very high, then the strength is very high. If these C and phi are very low, then the strength is low. So shear strength is tau. And if you remember your equation, it says tau equal the normal stress multiplied by 10 phi plus C. So this is this is tau, which is the shear strength of the soil. And I will divide it by what? By the shear stress. What is the difference between shear strength and shear stress? Shear strength is the ability of soil to carry load. Shear stress is the load on the soil. I am a weightlifter, I can carry up till 200 kilos. But what I'm carrying now is 100 kilos. So my strength is 200, but my stress, the actual stress on me is 100. So my factor of safety will be 2, because I can carry up to 200 and you are just giving me 100 to carry. So you now know what is the difference between shear strength means capacity, how much I can carry in any case. But shear stress means what is the stress in this case? What is the stress due to the load that is applied now? It may differ in the future, but now it is a certain value. Okay? Now, if you remember this equation, this is the equation that you are using in your lab report. Tau, this is the equation of the line. You said that we are going to draw a best fitting line. This is the equation of this line. Tau, which is the shear strength, equal sigma, which is the normal strength, sigma n, which is the normal stress, multiplied by tan phi. Phi, we said that the inclination angle of the line, plus c, which is the intercept of the y-axis. You remember your test? I think it was, let me, this is the results of the test. If I have 2 or 3 points, I just put these points, I get this number, this line. This line is exactly the same line that, this is the equation of the line. Sigma equals C plus vertical stress multiplied by tan phi. Let's see. Sigma, tau, which is any value here, equal the C, which is, if you extend this line to meet this will be the value of C. So it is C plus whatever portion of this line I will take in my study. If I want to reach this point, then it will be this value, which is the vertical normal stress, multiplied by tan phi, which is the inclination angle here. So you will need to study the lecture for the previous lecture, and now you study this lecture so you are going to get this shear strength of the soil. Once you get the shear strength, divide it by the shear stress which is acting on the soil, you will get your factor of safety. There are many factors of safeties. This is factor of safety with respect to shear strength. So if I tell you what is the factor of safety, you are going to tell me factor of safety in terms of what? In terms of shear strength, or in terms of moment, or in terms of what? So, in terms of shear strength, then this is the equation. It's shear strength divided by shear stress. In terms of moment, then I should calculate the moment acting, the driving moment that causing the slope to fail, compared to the resisting moment that is preventing the slope from failure. So, this is the equation of the driving moment. This is the equation of the resisting moment. Of course, it is not an equation. I will just show you here. If I have this slope, you see this slope. I want to calculate, this is a structural problem. If I have here, this is the load, this load is the own weight of this wedge. And this load is the weight of this distributed load. If I tell you, and here there is friction along this line. If I tell you what is the driving moment, what is causing the slope to go down, you are, in terms of moment, you are going to tell me this W multiplied by x1 plus this load multiplied by x2. This is the moment that wants to go down. What about the resisting moment? The soil itself is one piece. It does not want to split. What is preventing it from splitting? The frictional forces between particles. So I will take all the frictional forces along this line. What are these frictional forces? This is the frictional force, and I multiply it by the radius. I will get force multiplied by radius multiplied by the full length. It will give me all the force that is preventing the soil from failure. I will divide both together here. I will just if we say that this is the driving, as we said, the driving will be weights multiplied by arms of forces. Here, weight multiplied by arm, weight multiplied by arm. This is what we are going to do. For the resisting moment, it is the shear force multiplied by the radius. The arm here is the radius of the rotation, multiplied by the length of the arc. We said here, this multiplied by this, I should also multiply it by all of this length, because if this in this centimeter I have a force, then in the next centimeter I have another, and so on till I reach the end. So I multiply it by the full length here. I will not continue more than that in this lecture, to give you a chance to study and then complete what we have reached. But this is the driving moment, this is the resisting moment. If I divide the resisting moment by the driving moment, I will get the factor of safety. Next time we are going to apply this to many shapes of slopes to get the factor of safety and see how we can solve a problem in that. Thank you, and see you next week.